Welcome to the Artificial Intelligence Podcast with your host, Dr. Tony Huang. Today, I'm here with a special guest, Fernando. Could you please introduce yourself and tell us a little bit about yourself?
Hi, my name is Fernando. I'm a vice president at SandboxAQ, and we work on the merge of AI and quantum technologies since for the last 2 years since we founded the company.
Wow, quantum tech. That's really exciting, like a very exciting topic. Like, how did you become the VP of Sandbox?
It's we started a long time ago. I think I can tell a bit of the background. I started engineering back in Spain and Paris, and then I started working in the energy industry in Mexico City and Latin America. Then I joined Google, where I started getting introduced in all the technology world into spreading Google digital advertising and all the Google partnership products, all the products from Google that don't did not really make revenue at that time, or it wasn't the main product of Google, like Google Maps, for example, or Google News. And then I started working with Google X on some energy projects. So I linked the two loves that I had, which was more deep tech or engineering and energy, and moved to San Francisco to work for Google X, which is the incubator of Alphabet, where we create new companies for Alphabet. Then I met with Jack Hidary, who was hired by Sergey Brin, founder of Google. We were exploring the merge of AI and quantum physics. And we discover all these new verticals in AI simulation, in sensing, and in cryptography and communications that were not being that much explored in the industries. And 2 years ago, we launched SandboxAQ with Eric Schmidt as our chairman and great investors as Guggenheim, T. Rowe Price, Jim Breyer. And since then, we have the company focus on challenging problems and making an impact through software solutions in AI and quantum.
Wow, that's a very high skill set. It's like in the past couple of years, have you noticed any cool trends that you've observed that's like kind of eye-opening? Like for me, for instance, I thought one of the coolest trends was the emergence of like edge computing that was like super, super hot, I'd say 2 years ago. And then all of a sudden Gen AI came into the picture and then now everyone's doing Gen AI. So it's cool to see these trends come and go. What were like some big trends that you saw?
It's very interesting working on this space, AI and quantum technologies together, because we've seen a lot of changes in the last 24 months, for example. Something that is really coming up, it's AI simulation. AI simulation, when you combine the properties of AI, LLMs is one of them. It's one piece of the puzzle, but it's not the only one. For those of us that have been in the field or in AI for the last years, LLMs have been there for a long time. It's booming right now. But transformers came from Google and they've been there for a long time. And so you see that applied to how AI is enhancing and allowing us to use even more quantum equations and allowing us to understand the physics and the atomic world. So that's very impressive. And that wasn't able to be done before 24 months because the advances of AI and the connections with the hardware, the GPUs, how we use the GPUs today, it's been an incredible advance the last 24 months that it's allowing us now to develop new simulations for proteins, for new materials, for new energies, and radically change these industries.
Yeah, the right now AI is like the absolutely hottest field to be in. Like every single company is deploying some type of AI into anything and everything that they're doing. Like, where do you see this whole AI trend headed towards? Do you think that we're going to be spending a lot of our time in the near future in like Gen AI? Do you think that like a different type of like niche AI like framework or like focus is going to take precedent over like the current Gen AI craze? Where do you think like everything's headed towards?
It's a great question, and we keep on discovering new models that are helping us to solve different challenges and problems that raise every day, right? I think on the AI side, most of the Gen AIs right now focus on the LLMs, but there is much more behind and much more we can do with it. And it feels like it always happens very similar with the technology, like the internet. You start using it for one thing, but it's just how you're going to use those models. Like I was mentioning before, another trend that has been happening in the last 24 months. It's how many more countries are joining the quantum revolution and launching the quantum national programs. Today, for example, one of those applications is how we are using AI to bring those quantum technologies closer to reality, to solve world problems today, not tomorrow. One of the examples is, for example, how we use them in quantum navigation. Magnetic navigation have been there for a long time, but now today, thanks to the advance of AI, we are able to read what those sensors are telling us. And we are able to position some magnetic sensors on airplanes, like we're working with the Air Force, like we're working with a Boeing or AQ. And we are able to read where we are in real time when we don't have access to GPS. It's the new models are going to keep on coming, but we have to remember that AI is an other tool. So it's how we're going to use the tool that is really going to change and impress or really have an impact in the society and the world.
So you said the word quantum a couple of times. For the viewers at home who might not know what quantum is, it sounds like a physics term. Could you break it down into something that's a little bit more digestible? What is quantum, and then like how are like researchers and people in industry using it and deploying it into solution? And
Definitely. And that's one of the missions or the goals that we have as technology innovators. It's break that wall of quantum equals quantum physics, and it's all only for the physicists. I can share that, for example, I'm an industrial engineer and I rediscover, because I studied this in college, but I rediscover quantum technologies in the last 5, 6 years. And we hire many people. There's not enough talent out there. So we hire many people that are not quantum physicists and we train them and we allow them to discover this field. So what is quantum physics? When you think about AI simulation, for example, when we think about, let's going to try to solve Alzheimer or Parkinson or pancreatic cancer, we think about, okay, if we wanted to run a simulation today with the classical world, we run a simulation with zeros and ones because that's how classic computing works. That's just an approximation. If we want to really understand how the world behaves, how nature behaves, how our body's biology behaves, if we want to create a new material and we want to go to the chemistry level and to the atomic level, we have to go down to the quantum physics equations because that's how nature behaves. They use quantum physics. So for those that are not familiar with the quantum physics, quantum mechanics, quantum technologies, quantum world, and a good way to explain is that you have Newtonian physics that I explain. That's what we learn at school, in high school. It explains velocity, force, if you push, if you throw an apple, how it's going to fall, etc. When you go to the nanoscale and you go to really to the atomic level and you want to understand how ions, how the nucleus works, how they move in the electrons, and how they interact with each other, there are different laws that explain those behaviors. Those laws are called the quantum physics equation, the quantum mechanics. And those laws are not new. Even if people are going to start hearing more and more the word quantum around them, those laws have been existing for 100 years. So if you, for example, have been to a hospital and you've taken an MRI, that means you've been inside a quantum machine. Nobody thinks about it. It could have been called a quantum sensor, but it didn't. And they call it an MRI. But that is a sensor that is measuring the magnetic field of the atoms inside your body and making that image scan of your brain or your knee or wherever you're trying to sense. So it's not something new. It's something that has been there for 100 years. Today, thanks to AI also, we have the capacity to use those tools, and it becomes an engineering problem to solve problems. It becomes an engineering problem to really bring the solution and bring new solutions for our everyday problems. Does that make sense?
yeah, absolutely. And also, speaking of chemistry, it looks like you guys recently acquired a company called Good Chemistry. Can you describe what Good Chemistry does and like why you guys bought Good Chemistry?
Of course. Good Chemistry, it's an incredible team of experts, computational chemists, biologists, and it's been a great acquisition for us because it aligns perfectly with the AI simulation that we're doing. So this is going to transform literally many industries, including agriculture, biopharma, chemistry, construction. If you want to find a new material, for example, that it's less contaminating, that it's more sustainable, You need to develop this material that has the same properties, the same flexibility, and the same resistance, but that is sustainable. We cannot use the traditional methods that have been done until today. We can't just go with try and error. Same with drug development. We can't take 10, 15 years to develop a new drug. We can't spend 2, 3, $4 billion to discover a new antibiotic. So we have to be able to simulate all those processes and to be able to do it in years, not in decades. And for that, we need to be able to simulate nature. So good chemistry is bringing that product and that knowledge with a great talent team, and it's joining our already very successful team. We were working with Novonix on discovering new energy processes and new energy batteries. We partnered with NVIDIA, where we're using the GPUs to try to reorient them to use quantum physics equation to solve these kind of simulation problems that we have. So Good Chemistry is a great team based in Vancouver. They join our company, and we are both working together on solving these great problems that are gonna radically change all these industries.
Yeah, that's really cool. So background about myself, I did simulations in quantum like chemistry. So I actually know this field quite well. Yeah, not a lot of people know this, but I am quite well versed in like molecular dynamics and simulations, more specifically in like the protein and the RNA world. So I know that space quite well. And so I see a lot of value coming from using your approach. And I'm quite curious as to, you guys recently announced a collaboration with NVIDIA in the simulation space. Could you tell us more what the goals are with this collaboration? What are you trying to accomplish? Are you just trying to get more GPUs so you can basically build bigger and bigger simulations? Or is there like a more like strategic plan where like you guys have thought up like this like new framework or this new package that you're building together? Like what's happening there with that collaboration?
NVIDIA is a great company, and they have a great culture with working with developers and with working with the latest trends. They've always been able to figure out what's coming. That's where you see the changes in NVIDIA stocks the last year, the last 2 years. It's because they're very good at going to the market and listen to the engineers and the people that are really using their hardware to make a change. So when we work with NVIDIA, NVIDIA is a great company that has always been very good at understanding the trends in the market, because they always work very close with the engineers and with the developers, and they build a hardware based on what the market is using it for. But when we want to understand the strategic alignment that we have with NVIDIA, and they have an entire quantum team already because they know this is coming, they know this is here right now, and that the developers are asking, we want more hardware to be able to run these new kind of equations. But we have to understand where it comes from. It comes from video games, right? NVIDIA started designing for the graphics for the video games. So then they repurposed it. They repurposed the hardware to be able to run the machine learning models. So they saw that coming, and now they saw coming what the AI was going to do, and they started repurposing the hardware again to run different kind of AI models. That's what now every company is using NVIDIA hardware, because everybody is into AI. So they understand as well that quantum is going to be a huge innovation for every field. What we talked about before, biopharma, materials, energy, finance, quantum is going to be everywhere. And they're doing the same thing with their hardware. So there's this strategic alliance, but for that, you need to be able to design new software algorithms to repurpose again that hardware to run those new equations that we talked about, those quantum physics equations that describe nature using GPUs. And that's what we're doing today. The simulations that we're running, they call them quantum inspired, for example, because also they run quantum physics models to understand the molecules. They're not using a quantum computer. We're running those equations on GPUs from NVIDIA. And so that's something you can do today, and we are doing today, actually. Once we have the quantum computers coming, we start using the quantum computers. But today, there's a lot you can do using AI and quantum physics together.
Yeah, it's exciting to see where the simulation industry is headed towards. Like back when I used to do simulations, it was all CPU based, like it wasn't GPU based at all. You'd have a head node that controlled a bunch of like slave, like CPU thread rippers, and it would take weeks to do simulations on those CPUs. Obviously, it's because of the architect, but now that models are becoming much more like much more advanced, much bigger. You can't like you basically can't put it on a CPU anymore. It's just it's not feasible. Everybody's switching over to GPU computing because of the horsepower that you can get. And that's where like Nvidia is basically like the king right now in terms of computing because they're the A100s, the H100s, the H200s, they're in extremely high demand because everybody and their mom is using that hardware with the CUDA to create these brand new frameworks, these brand new models that's propelling that industry forward. And so it's cool to see like that shift from everyone's doing CPU based computing and now they're switching over to GPU based. And now there's a huge demand from one company to another. I like to see that type of movement so the industry is not stale and stagnant. So it's very refreshing to see companies in the biotech space taking advantage of these like next generation architects that are coming on board. Yeah, so I'm very excited to see like your point of view on like how do you see like the advancements in say like AI, quantum, cloud computing, high performance computing, like really transforming the field of like material science and chemistry. Like where do you think that's going? I'll give you like, something that was on the news that I thought was interesting, which is Microsoft teamed up with a company for material science development, and they were using like high performance computing with AI, and they were able to like chug through just a mountain of data that would have taken years with a traditional approach, and they were able to do it in a matter of hours, and they were able to identify like new materials for use in lithium ion batteries. And that type of study really showcased like the coupling of like high performance computing with AI to like transform like the space of lithium ion battery material science so that like everybody could use it in the future for like electric cars, like some type of EV based transportation. And obviously that can be translated over to any other amount of fields that have just a mountain worth of data. So in your point of view, what's like the big advances in that in regards to chemistry and like material science? What's your take on it?
It's First, it's incredibly exciting just to see advances like you mentioned every week. If you follow this field, every week there is a new announcement. Every month we break the new record of the biggest computation ever done, either with a classical computer or with a quantum computer or with any other kind of approach. And that's very exciting. It's also very exciting, in my opinion, that there are so many players working on this. Yeah, when I talk about players, I talk about the private industry, the public financing, academia. So you have more than ever, more people than ever working on these fields in terms of PhDs, chemists, three people, computational chemists, biologists, all working together. And in the world, I'm talking at the world scale. And this is fascinating. So you can think about the acceleration that is going to happen in the next 5 years is going to be more than ever before, just because of the number of talent that is working on it. If you add to that, it's like a soup. If you add to the soup AI, which is also accelerating how we are progressing and how we are able to put together different kind of tools. And for example, the other day, IBM, for example, was mentioning how they are now using also AI to learn how to better build the quantum computers, how to make the qubits interact with each other. And that's going to accelerate probably the roadmap even better. You mentioned Microsoft. Microsoft announced 2 or 3 weeks ago that they arrived to a new battery material using AI first to reduce the number of candidates that they wanted to simulate, and then quantum inspired physics with classical computers to really simulate those new end of structured materials in chemistry. And again, using AI and then quantum. And they found a new material that they would have never been able to find before because there are trillions of different combinations in chemistry. So seeing all these players doing all this, I just think it's fascinating, and the results are going to be unbelievable and much faster than we think. I'm a very positive person in this field, and it's going to transform everything that we know because chemistry, it's the foundation of nature. And once we are able to simulate nature, we can understand how things really behave at every different scenario of our lives. We're talking about biology, our bodies. Can we create antibiotics that are customized for your body because we understand exactly how they combine the proteins with the structures inside your body? can we create the new batteries? For example, we talk about the electrical revolution. We can have an electrical revolution if we can find a way to transport renewable energy to where it's produced, to where it's consumed. If we can find a way to store energy in a way that will reduce the cost. And for that, we need new kind of batteries. And batteries is about chemistry, and chemistry is about quantum physics. So we're just gonna change every industry as we know it today.
Yeah, the cool part about that Microsoft article wasn't just the fact that they discovered brand new like compounds, but the results show that two of the compounds that they have already made were they successfully made it and tested it and verified it in real reality that it did work. So they used it to validate to double check to make sure that the compound that they actually made actually did work in the simulation. So I find that really cool to be able to not just use AI with high performance computing to invent new things, but also to use it as a validation step to make sure that the stuff that you've built does actually work in simulation as well as in the practical world. That, in my opinion, is like if you couple those two together, using it to not only build new things, but using it to validate the existing products that you've made, that's absolutely killer, in my opinion, in terms of the simulation world. So
Correct.
I definitely think that's where everything's going to head towards, is they're going to find out that, oh shoot, this is actually a really good validator. So we're going to be using this to validate things in the future. And right now we're in the honeymoon phase where I feel as if everyone's wowed by the capabilities of AI. So they're trying to build new things, but they're not realizing that you can actually just use it to validate the existing product lines that you've built. So again, it just requires a different type of thinking in order to use these like next generation frameworks and products that are coming out on the frontier. So
Yeah, it's a new approach, and it's really good that more players are starting to use this approach. SandboxAQ was probably if one of the pioneers in this field, combining these two AI and quantum physics approach. But it's good that more and more in academia, public, private are joining forces and trying to solve these problems.
yeah, so I'm interested in knowing what you guys are doing in the future. Spill some beans. Tell me some insider knowledge on what you guys are building. Anything cool that's on the horizon that I should keep my eye on?
I'm limited about the amount of projects that we can share so far. I can tell you we're doing AI simulation. For example, we announced a recent project that we're doing with a Nobel laureate on Alzheimer, and we had great success in that field, achieving some kind of simulations that the team hadn't been able to do for the last decade. And that's been a great confirmation for the approach. We reduce years of work into a few months or maximum 1 year. And that's a great validation for the team. That's a great validation for the impact that SandboxAQ is having. We're working with Novonix, as I mentioned before, on new batteries as well. We're working now with Dow on new materials with good chemistry as well. And we're working with many other pharma companies and developing new materials with other players that unfortunately, we can't share yet. But there are almost unlimited ways of running simulations that we can imagine from like the new materials, but also on the sensing space. On the sensing space, we have devices in hospitals that are measuring your heart. There's the heart diseases are #1 cause of death in not only in the US, but in the world. Having the right sensor that is measuring your heart and tells you what's really wrong, that's EKG is not good enough for that. EKG, electrocardiogram, is what if you have a heart attack, you go to the hospital and you get your heart sensed. They're using an electrocardiogram machine. So that measures the electric field in your heart. What we're doing right now is we have these devices in the hospital measuring your magnetic field in your heart, that it has a different 1 or 2 more magnitudes of accuracy in terms of being able to read what's going on in your heart. And that's going to be revolutionary because we're going to be able to detect heart attacks that before were not able to be detected. So on the sensing space is also another space that it's huge. It has a incredible potential. It's basically, as we talked about before, it's the MRI, but enhanced to the next level. The quantum navigation that we're working on as well, or magnetic navigation, if you want to call it, we're working with the Air Force. GPS is a huge problem out there. GPS can get jammed many times. It happens in conflict areas like Ukraine right now, like in Middle East. But the problem is that also many commercial airplanes are losing GPS. Ships, navigator ships, containers are losing GPS, and there's a huge problem worldwide. And it happens more and more often. So they have a few other techniques to navigate, but if birds and whales can navigate using the magnetic field of the Earth, we can do it as well. And we have the magnetometers and that we build ourselves, but also we have the AI that we apply to it that allows us to denoise, that take away the noise from the airplane, take away the noise of any other magnetic field that we don't want to read, so we can focus our device on the magnetic field of the Earth and know exactly where we are without having to connect to any satellite. So those two products, for example, are linked to the sensing space, and the sky is the limit for sensing. If you can sense basically anything, as long as what's the magnetic field of the atoms that you're trying to sense.
Yeah, all those sound really like great use cases for simulations, and I'm sure that a lot of the viewers at home are getting their brain juices going, and they're probably wondering if they come up with an idea, how would they contact you? What's your contact information?
They should go to SandboxAQ.com because we have our website. And our website, for example, we have an entire site dedicated for education. We have our YouTube channel where we create a lot of content. And one of the things that we recognize is the lack of talent for the next 3 to 5 years. And we are here to help. We have a learning platform where we give access to all our partners to the content. We like to share everything that we're working on because we want the partners to understand everything that we're doing. So they know as much as we know. We're here to help, to work together, to solve the same problems that they have. We go to universities. We've partnered with more than 50 universities. We launch quantum master programs within NYU. And we want to have more and more engineers, more and more quantum experts working with us. The suggestion is go to the website. You have all the information about the use case that we've done with the defense, with the private companies, in healthcare, in cryptography, in the sensing space, with the hospitals. And then you can navigate as well and see all the content that we publish there. Because once you start learning this field, you get really passionate about it. Once you start discovering everything that is possible, merging AI and quantum mechanics, you can only imagine the future.
That's really exciting. What's your vision on what do you think is going to happen in the future in terms of AI simulations? I'll give you something that I'm predicting, which is right now, a lot of people are using the transformer architect in the AI world because it's the hottest type of architect. Not a lot of people know this, but if you use this transformer architect, it actually requires like a ton of RAM. In fact, it's like a quadratic problem where like it requires just so much RAM, VRAM in terms of the GPU computing that a lot of people can't. The average person doesn't have access to the amount of RAM that's needed for these large models. And so, like on the horizon, what I'm seeing is that there's a new type of framework that's moving away from like transformer architect, and it's more of a linear scale. So like you're able to scale linearly in terms of the amount of parameters versus the amount of VRAM for GPUs, so that you're basically, long story short, in the near future, you should be able to run very large, like parameter sized models on smaller amounts of GPUs. So that would help out a lot in terms of AI in general, with AI simulations included. What's your predictions in terms of the next big thing that's going to happen in this AI simulation world?
Oh, the next big thing. Let's see. Building up on what you mentioned, you can see, for example, the cost of LLMs going down, dropping because of the competition, which is excellent for all the community to use it. Because if you had a high cost, you will have a few players using it. But it's so relevant, it's so transformational for every business that it's making everyone launching even open source models that are really good that you can use. And it's commoditizing the LLMs. And then you have different techniques that are coming out, right? Like retrieval augmented generation, or new NLP, or natural language processing models, or vectorization. So every time you get a limit, because it's so critical to every industry, to every business, and everybody goes into it, there's some kind of like a Smith hand, invisible hand that makes the market balance. And that, I feel, it happens as well between the hardware and computation needs. The AI simulation is so critical for every critical sorry for being redundant, but the critical infrastructures and critical industries like pharma, like energy, like finance, like healthcare, that when you have all these players going into one direction and starting to use the AI simulation, the hardware is catching up. And when you talk to the chip manufacturers and from the R&D centers on what they're working on, they're catching up. They're not going to be lag behind for the needs that we're going to have on simulation. And then if, because so far the classical hardware, the GPUs, have been catching up every time. And the quantum computers are coming in parallel. So, which are going to bring another new tool of hardware capabilities that are going to be able to run even more simulations in a different way and even more computation. So I'm only positive about the kind of simulations that we're going to do. I really want to see the first drug that is developed in a time record. And when I talk in a time record, I'm talking in about 2 to 5 years, not 10 or 12 years. And that's something that is very exciting.
Yeah, yeah, those timelines, they're typically like 10 plus years and they're very expensive. I used to do that way back in the day, and I'll tell you, it's not fun to be in that life cycle. So
It's crazy, right? You're in half of your professional life,
yeah,
and you've never seen one of your work coming out to the market.
yeah, you will never
15
see
years
it.
working on something, and maybe you've never seen.
Yeah. So for people who don't really know like drug discovery, it's like this big triangle shape, right? Where on the left side is like the discovery phase, and then on the right side is the actual deployment of a drug. And that entire timeline is like 10 plus years. And so you go from like the laboratory setting on the left side to like mice testing on the center and then human testing on the right side. And that those steps take so long because a lot of the traditionally a lot of drugs are created using organic chemistry techniques, and organic chemistry techniques take months and months just to produce a couple compounds, because if you like mess up on any one of those steps, you got to start over again, and the sheer amount of product that you get from every single like chemistry step is it like diminishes as you go along the life cycle. So by the time you're at the very end, you just have this tiny little compound, like this tiny little bit of compound, and that's the thing that goes into like mice testing. So it's so using like next generation tech in order to help reduce that timeline is great, because like now we're able to like service humanity, right? We're able to bring out cures, vaccines faster so people can live longer, they can stay with their families longer, like this they can stay healthier longer. So this is a great mission that everyone's in the biotech is having right now on their journey using AI to better humanity. So this is like one of the coolest like topics in my opinion, because it really resonates with like all of the pain points as a like a hard scientist like I was like back in the day, right? So now all of those problems are being alleviated with these cool infrastructures that are coming out, these great models, new way of thinking. And so what I know is that in the university, in the higher education sector, there's a big push to put AI into basically every single major. So if you're in college right now, you're listening to this, or if you have kids that are entering the college, just understand that regardless of what major you're in, there is an initiative at every single university to put AI into every single major because of how important AI is. Now,
Mhm.
with that being said, I'm sure there's a lot of people that are listening that are very interested in coupling like AI with the hard sciences. So my next question is for people who are beginning their journey in the hard sciences, but also want to use AI so that they can use it as a force multiplier. Like, where would you start in terms of like resources, like YouTube videos, like Googling around at certain forums? Like, what is a good starting point to get somebody in that field started using AI?
The good news is that AI is also going to help us to learn and to study. We just launched at Davos AI with LibreText, where we build a tool that it's basically trained using the literature and the education. In LibreText, you have terabytes and terabytes of data. And we use that data to build the AI tutor. So you can ask information all the time, but it's focused on the data that you want. Because we use RAG, what I mentioned before, retrieval augmented generation models, that it's you can train your model using external data that is focused on a topic that you want your your LLM to be an expert on. So now with that, you basically have a tutor for you to help you with whatever you need. And if you want to learn a little bit more about AI, you want to learn a bit about quantum physics, you're going to have that person that is going to be adapted to your needs, to your style of learning. You also have a lot of YouTube videos, right? The difference between when I studied quantum physics in college and to today, in my college, there was not YouTube or not much. Not, so you had the book, the equations, you had to learn it. That's it. Today, you can try different styles and you can go around YouTube until you find that teacher that you find affinity with and that you love the style. And then once you find that one, you just get embedded into it and just can't get out of it. So between that and AI as a tutor, it's just a matter to start. It's just, and as soon as you find your perfect match, it's just, you're going to keep on going. So AI to help you learn AI.
Thanks, Fernando, for being on the show. And until next time, stay curious.